We congratulate the workshop participants. We are glad that in this difficult period for Ukraine, we have the opportunity to report at this conference. We want to present a report on the topic, decisions to prevent pollution and restore the environment within the impact of abandoned oil and gas wells. Oil and gas facilities pose a potential environmental hazard, both due to the presence of aggressive chemicals in technological processes and due to the large number of these facilities in all regions of the planet. The consequences of oil and gas production, which occur during the life cycle of wells, cause significant environmental damage and in many cases form irreversible changes in the natural environment. The commissioned oil and gas wells pose a danger to the environment, as most of them produce methane, which is a powerful greenhouse gas and one of the man-made factors that weaken the stability of the planet in the context of global climate change. The problem of abandoned oil and gas wells is common on all continents. The number of abandoned oil and gas wells is not fully established. Determining their number is complicated by the fact that many of the abandoned wells are lost without any evidence of their existence on the surface. On the location of the man-made object, in our case oil and gas wells, the degree of environmental risk from the conducted activity depends. In the western part of Ukraine, oil and gas facilities are located near natural and recreational areas of national importance, Truskavets, Skirnitsa, Morsh, and Bukovad resorts, which creates a high risk of man-made disturbance of valuable areas. Then the main negative impact are on the surface layer of the atmosphere and surface and groundwater. The areas of distribution of pollutants may become transboundary. Factors of natural origin can also increase the degree of risk, in particular for mountainous areas where there is a high risk of mudslides. Pollution prevention is currently a top priority in most countries around the world. US Congress establishes a priority national policy: contamination should be prevented or reduced at source possible. The global negative impact of the oil and gas industry consists of the local impacts of individual facilities. Therefore, addressing the environmental issues of individual facilities, including decommissioned wells, is one of the main tasks to improve the environmental safety of the industry. The main tasks of this article are to analyze the probable environmental impact of the old stock of decommissioned wells, to investigate the species composition of PHYTOCENOSIS and the taxonomic characteristics of the oil-contaminated ecosystem plant groups, of equipment methods for decommissioned wells restoration, to offer a range of equipment for abandoned wells restoration, to determine the principles of environmental safety management of the old found abandoned. Currently, the planet is exacerbating the negative effects of global climate change. A significant number of extreme weather conditions, floods, increased geodynamics, and more. Seismic movements can activate these wells and provoke accidental oil and gas emissions. The result is the transformation of large areas into areas of ecological disaster. Tightness of wells during their conservation is designed for 20 to 30 years. Over time, the cement bridges in the well may collapse. The mouse equipment and the column itself may corrode, causing the well to depressurize. Such wells are a source of methane in the environment. Plants play the role of primary absorbers of man-made pollutants and phytomeliorates of the environment, and at the same time can reflect at different levels of biological organization the degree of anthropogenic transformation of the environment. The analysis of phytocenotic diversity was performed on 3 sites with an area of 25 square meters, located around the source of oil pollution according to the tested method. Figure 2. The nature of the location and projective cover of the species in the phytocenosis was determined by the Brown-Blanke method, and the identification of species was conducted using the electronic determinant FunSnap and the reference books. The taxonomic characterization of species was performed in the laboratory. The phytocenotic diversity of the study areas is represented by 15 species of herbaceous plants. The nature of the location and projective coverage of herbaceous plant species in the phytocenosis of the oil-contaminated area are given in the table. Thus, in the conditions of oil pollution, a stable phytocenosis was formed, represented by a small number of species of herbaceous plants, most of which have adapted to adverse living conditions. Most of the abandoned wells are low flow due to the complications and accidents which led to the abandonment or conservation. Therefore, one of the first stages of technical and economic decisions should be research and repair work in these wells. It is necessary to select modern, reliable, highly efficient devices, equipment and special tools for cleaning wells from destroyed equipment and other necessary items and dirt. In the process of descent into the wells of long-term equipment, it is necessary to monitor the condition of this equipment. Due to this, it is advisable to use a rod magnetic flow detector. The essence of the device is explained by the drawing of figure 3, which shows a general view of the rod magnetic flow detector in working condition when passing through the protrusion and coupling of the rod or pipe when descending into the well. This control will prevent damaged elements from flowing into the well, which could cause additional complications. To accelerate the unscrewing of pipes or rods left in the well, it is advisable to use a device for unscrewing the pipes in the well. Figure 4 shows a laboratory experimental sample of the device. In addition, the proposed design of the locking elements allows the device to be used in casings of different diameters without replacing the locking element themselves. To prevent the absorption of liquid in the process of washing the well, it is advisable to carry out foam washing. And to obtain a fine stable foam, it is necessary to use a foam generating device. This foam generating device has a positive effect due to the introduction of a multi-nozzle insert. In the chamber of turbulent motion of the flow of the mixture placed in the diffuser is a process of consolidation of the obtained effect. A stable controlled foam mixture is obtained. Therefore, there is a need to develop strategic solutions based on the principles of eco-efficiency to prevent environmental pollution during the life cycle of oil and gas wells. The main positions of the strategy are to analyze each stage of the life cycle for the possibility of reducing not only output flows, such as emissions, discharges, waste, but also reducing the flows, which involves resource conservation and efficient use of energy. Achieving such effects is possible with the modernization of existing technologies and equipment. Constant control of wells decommissioned by developing innovative tactics for the involvement in the life cycle of energy flows. Reduction of the risk of emergencies by monitoring the condition of equipment, timely diagnosis, and selection of criteria for equipment perfection. Development of forecast estimates in emergency situation, particularly in gas and oil pipelines and open fountains, which will allow to make effective management decisions for rapid localization of the accidents and reduction of negative environmental effects on the environment. Formation of the environmental safety management system at all stages of the life cycle of oil and gas wells, based on the principles of sustainable development, eco-efficiency, and continuous improvement, by adapting best practices of development countries and developing their own management approaches. The process of well restoration is complex and requires a significant number of specialists and resources to achieve the expected effect. The work should be carried out systematically with the planning of successful stages. Equipment and methods of restoration of abandoned wells should be determined individually according to the characteristics of each well and the specific of the landscape. Selection of plant biological indicators and biological remediators of technogenic change territories should take into account climatic zonation and their biodiversity. Thanks for your attention.